Hi, my name is Michael Swan. I'm leading this project. Welcome to the Pass the Butter project. For this project, we endeavored to provide the least efficient way to transport lipids. Our robot was built to question its own existence while being needlessly complex and hopelessly undertasked. Enjoy.
What is my purpose?
Pass the butter. Thank you.
What is my purpose?
You passed butter.
Oh my god.
Yeah, welcome to the club,
man.
pal.
My name is Annika, and I worked on the CAD for this project. We first decided to model the drive base through Autodesk Fusion 360. It was basically a replica of the drive base that we bought directly off of Amazon. The main reason we wanted to make sure that our drive base was modeled first was because it would be easier to assemble the other components of the robot, such as the arm, camera, Jetson Nano, the speaker, etc. It would also ensure that everything would fit on the robot as well, since we tried our best to model the drive base exactly to size.
My name is Misha, I'm a mechanical engineering student, and this is my first semester in Makers. And I'm moving on to the arms. So our initial arm design consisted of 5 degrees of freedom per arm, which we realized is probably too excessive for passing butter. So we eventually scaled our design back to include only 2 motors per arm, the shoulder and the elbow. After that, we modeled a piece to connect the arms to the camera and put them on a vertical sliding rail. And lastly, we assembled every component that we've individually CAD'd thus far into a single model, imported electronics to position everything, and have the final product ready to assemble.
Hi, I'm Efaz, and I worked on the electrical design of the robot. In order to get the robot to work, we needed to design the electronics such that it would be able to sense the environment around it and move properly. Our electrical design consists of microcontrollers, a depth camera, a microphone, various sensors, servo, DC, and stepper motors, as well as their drivers, and a buck converter. When creating the design, we initially decided on using an NVIDIA Jetson Nano connected to 3 Arduino Nanos in order to interface with all our sensors and motors. However, we realized that such a design would make the communication process complicated. Instead, we were able to remove 2 Arduino Nanos by moving the ARM electronics to the Jetson Nano, using the single Arduino Nano for locomotion and sensors. By doing so, we were able to simplify the control structure needed for interfacing with the electronics.
Hi, I'm Sarah, and I worked on simulations. Because the physical bot took some time to be built, we decided to use some simulation software like Arviz and Gazebo to try to get working on the controls and other software aspects of the project. It didn't exactly work out as we had intended, but we did create some really cool stuff in the process of working with these programs. I created a URDF model, which just models the bot's physical properties, and it's used in Arviz and Gazebo when we're just doing like basic simulation work.
Hi, I'm Max Ginsberg, and I was part of the assembly team, and I CAD'd and designed the entire head mechanism. Assembly of this robot was an adventure of its own. Luckily, only one coffee jar was sacrificed in the creation of this robot. The entire build took more than 20 hours to complete from start to finish, not including the massive 3D printing loads, including the reprints, as Misha and I kept messing things up. Sorry, Michael. Additionally, when ordering random products off weird Chinese websites, some of the things we receive are not exactly up to standard. One of the acrylic plates we have on the base of the robot not only broke when we tried to drill into it, but the pre-drilled guide holes are not symmetrical in any angle or placed in any sort of pattern. We glued it back together after breaking it, but it appears as though clamps and superglue should not be mixed.
The wiring was done to the highest standards of unprofessionalism. We used screw jacks on solid core wire, switched male and female wires, and left a general mess all over the robot. It was great. Overall, it was just a huge time sink, taking almost as much time as the rest of the assembly. We verified the wiring with a voltmeter though, and it seems to all work, so cool. Perception was planned around the use of the re-speaker microphone array, which provides directional audio, and the OAK-D camera that was made in collaboration with OpenCV and Luxonis. The microphone can be used to determine where a speaker is talking from, while the camera provides ranging depth, which can be used for simultaneous localization and mapping in ROS, that is, the robot operating system. In addition, the camera can be used to detect objects in its environment, such as people, plates, and butter.
Hi, this is Sam. I'm a software team member of the project. Controller was built from scratch to control the robot's position and orientation in order to get to the place where butter is located. It uses two PID controllers that receive feedback from the motor's encoders that generate speed output from position input and voltage output from the velocity input. Ensuring accuracy in position and orientation control is essential to locating the robot in the desired place in order for it to accomplish the mission of passing the butter.
Voice recognition is achieved through a combination of software packages. We chose to use Pico Voice for wake word detection because it's super simple and ultra lightweight. That second part is really important to us because we're using a Jetson Nano and we need to conserve our precious computational resources. Once Pico Voice hears the word computer or any other keyword that we specify, then it tells the actual speech-to-text service, in our case Amazon Lex, to begin listening. So the nice thing about Amazon Lex is this is cloud-based. And that means all the heavy lifting involved with speech-to-text is actually being delegated away from our Jetson Nano.
Hey guys, my name's Avinash Gala. This semester I worked on speech-to-text and text-to-speech with Spencer Lin. So first I'm going to ask the Pass the Butter robot to play the Rick and Morty theme song, and then I'm going to ask it to pass me some fruit. Let's see if it can handle all of that. Pass the Butter robot, can you first play the Rick and Morty theme song, and then pass me some blueberries? Good job, Pass the Butter robot.